I'm just going to start by taking a photo so that I can prove to my brother and my wife that people do actually come to watch me speak. So, thank you. Okay, so my name is Neal, and I'm going to talk to you about getting out of trouble with antipatterns today. So anyway, who am I? I work for a company. Is this going to click? No, it's going to fail. Okay. So I work for a company called MyBuilder. We are an online marketplace which matches homeowners up with tradespeople. And we have sister companies in the Netherlands called Workspot. In Germany, it's called Meyerhammer. In Italy, it's Instapro. These kinds of things are all part of the same group. And we all do roughly the same thing. Normally, at this point, what I do is I say, we are hiring, come and join us. But I don't know how much time there is left for people to come to London and be part of our team. But if anybody is thinking about making a very short career change into London, I don't know if we've got a week or if we've got 3 months at the moment. But we're a company, we do TDD and we do DDD and we do clean code and we do everything, so things that are right, so nothing that I'm going to show you today. Everything I'm showing you today comes from other companies, most of which don't exist anymore, so I don't think I can get in trouble for showing you what I'm going to show you. Quick show of hands, first of all, though. So back to what we're doing today. There are 2 versions of this talk that I can give based upon how much you want each one. So I can give the relatively clean and mundane version, or I can do the sweary version. So, okay, so hands up for the clean version. No, 1. Hands up for the sweary version. Good, right. Hands up if you didn't put your hands up just there. Okay, a couple of people. It's people that abstain, which is why Brexit is a thing. Okay, so I presume most people have heard of design patterns. Who has heard of design patterns or who uses them? Okay, a fair proportion of the crowd here. So design patterns are common ways of approaching problems in software engineering. So they're familiar problems and they're familiar ways of solving those problems. If you're not familiar with design patterns, this is a really, really good series, which gives a good introduction to it, because if you're not really familiar with UML and stuff, picking up the book and starting with it isn't always that easy. So I would suggest checking that series out. But I'm not here to talk to you about that. We're here to look at some shit code rather than good code. And so this book here, the Antipatterns book, was released not long after the design patterns book. And what this does is talks about problems that we see in software engineering and where we get it wrong. So whilst design patterns were familiar ways of solving problems in software engineering, the design patterns, so the anti-patterns are common ways of solving familiar problems that have got an unintended negative result. So basically, we just keep making the same mistakes over and over again. And then what we do is when we're doing things well, we go to conferences and we go to meetups and we talk about things that we've done right. But what we never really do is talk about when things have gone wrong. And spotting anti-patterns in your, it's a technique and it's a skill, but spotting anti-patterns in your company and in your code and in your systems helps put you back on the right path. So when you had visions of building something like this, but you've actually ended up with something like that, and your project manager looks at you every day like this, and you go home feeling really glum, then you've probably got some anti-patterns happening within your company. So the book defines 3 different areas of anti-patterns, 3 different types. The first are software anti-patterns, software development anti-patterns, software architecture anti-patterns, and also project management anti-patterns. Now, I'm going to give you 2 examples of each. We're going to spend most of our time on the architecture one because that's where you can really fuck things up. So the book gives us anecdotal evidence of where to spot that something might happen. So kind of like code smells, but more conversational pieces that you might hear. So we'll start with an easy one. So when somebody says, I thought you'd already fix that bug. Now, who's ever had that conversation at work, yeah? It's kind of familiar to people. Someone goes, wait, hold on, we fixed that 2 weeks ago. Why are we still seeing it? Well, this is an easy one. This is just cut and paste programming. Now, quite handily as well, the book tells us where the common causes and the symptoms of each of these problems that we have. So the symptoms of cut and paste programming is that you have the same bug keeps happening over and over and over again, and somebody's fixed it, but you keep seeing the same thing over again. The lines of code in your system increase more than the productivity does. That's not as obvious as thinking, oh, I've already fixed this, why do I have to fix it there again? But when you notice this thing happening, then this is kind of symptomatic of cut and paste programming. And excessive software maintenance costs. Your software maintenance spirals way out of control. So causes of this as well. So we have things like organizational emphasis is on short-term speed rather than long-term investment. So everybody's just cutting and pasting because they've solved that problem. We need to do it again quickly because the boss is on top of us. Development speed is considered to be a top marker of productivity. Lack of abstraction and poor understanding of how to achieve goals using object-oriented programming. And Stack Overflow as well, of course. But it's not just Stack Overflow, of course. It's people in general who, when they're not familiar with a new technology, they find examples that suit them, and then they just modify it to their needs. They don't actually bother to put any effort into understanding what they've just copied and posted. So how do we go about solving this? The first thing we do is we do some code mining. Now, my examples are going to be PHP, and I'm sure as soon as I say that, some people are going to be thinking, oh yeah, you're using PHP, that's why you've got shit code. We've heard all the jokes before, right? But you can do this, I mean, like, who uses like Ruby or Java or Python or anything like that? Not many people want to admit to it, actually. I'm not going to call you out on anything. But you can make these same mistakes in those languages. It's not specific only to PHP. Having said that, I'm going to talk about tools that are available in PHP. So for PHP developers, there's something called the copy-paste detector that you can install with Composer. If you're not familiar with PHP at all, Composer is just a package manager. So we can just install that into our system, and then we can run it. We can exclude the vendor directory. And what happens is it tells me, it says, I've found 35 clones with nearly 2,000 duplicated files in this project. So this is a real project that I used to work with. This company used to pay me money to come and add to the mess that we had, to be honest. But this is, yeah, so I ran this on that code base, and it said we've got all of these clones here. And if I look at it, we've got something about campaign groups and something about campaigns. So this is kind of similar. So immediately I'm thinking, it's probably a collection of campaigns here, right? There's probably similar functionality, and somebody didn't know how to approach it. And what they've done is gone, we'll take campaigns and we'll make a collection of those things somehow in a different file. And we look here, some managed campaign groups and managed campaigns. It's all very, very, very similar. So somebody just copied one to make the other. Quite handily, it tells us the lines that are cloned as well. So we know exactly where to go and start looking. So now we can go ahead and start thinking about how to refactor that. So the first thing we need to do is well, the book tells us that we need to pluck reusable components. That's kind of familiar and obvious to everybody, right? There's nobody thinking, I really don't know what to do about this. So we need to go in and find where things are used and what we need to extract. So the very first thing that I did actually here was I started clicking on methods in my IDE. And it just went, this isn't used. So why the hell, like, how did that get merged into master? It's not being used, it's actually not needed whatsoever. So I managed to just delete a whole load of shit that actually wasn't necessary. And then what happened was in this managed campaign groups file, I think it's the groups one, is it? I can't really see it on there. There was one kind of method that really stuck out. And it's this method here, which is pass filters array. And I found that in that very same method in this other file here. So it's the same thing. The only actual difference between the two was the array that it was setting up at the beginning of it. Everything else about the algorithm in there was the same. And then I found it in a third place as well, just for good measure. So we'd actually got this same thing across 3 different places. So what we can do, quite obviously there, is refactor that to use a design pattern. And the obvious choice is to use the template method pattern here. So we create an abstract base class, and we put in a method that says, a method called getFilters. So yeah, so I create the abstract class here, and I create a method called getFilters. And then what happens is the concretions of that, the child classes, only need to provide that array then. So we've got identical classes, almost identical classes refactored into one base class, and then the only thing that's different is the array, and that's all that the child needs to provide to the whole thing. So we can, so we implement it here. We just extend that that base class, and we say, look, here's that filters array that you need, and then it only needs to pass in what it needs to pass in each time. This time, when we rerun the tool, we've got 4 fewer clones, and we've got rid of nearly 450 lines of code as well, just by doing this one thing. That took about 5 minutes to do that, and we're starting then to reduce the amount of shit in the system, and we're reducing developer, so the cognitive load on developers that are working on this. But how do we stop this from happening again? Well, the first thing actually is just code review. Get people looking at code, because at some point, when somebody's doing this, someone's going to go, I've already done this thing. Like, why are you re-implementing this thing that we've got? So that's the first one. That's a really easy kind of one that you can find and refactor easily. What about when you've got a conversation piece like, we're not really sure what that code does anymore, but it works, so we just don't touch it? I mean, I'm sure we've probably all been there. That is known as a lava flow. So what happens is, developers are contributing to code, and maybe somebody leaves the company. They wrote something that nobody else understands, and then they leave the company, and then things happen later on, and you need to make a modification. Everyone's too scared to do it. So what we find, the symptoms of this, is that we've got undocumented, complex, and important-looking code fragments throughout the system, which seem to be unrelated to the system architecture as well. And we have unjustifiable variables throughout the system as well. So it'll be sort of a variable that seems to make absolutely no sense in the context of everything else. And that'll be where people are trying to work around what they don't understand. Lots of to-do comments in the code. We all get that. And then there'll be large blocks of commented out code as well, where somebody's just commented something out and then committed it, and then nobody's ever questioned it. So the cause of that is often that research and development code gets merged into master and never actually improved. We have lone wolves working on the code, those rockstar, those 10x developers that we've all heard about. Shifting goals of the software project. If you write code and you don't know if you're going to need it because the goal of what you're trying to achieve keeps changing, then you've obviously put time and effort into writing that code, and it can be sometimes a little bit galling to then delete it. So I understand that people comment code out because of that. And also, just any kind of lack of architectural design or forethought to it. So what we have to do to refactor this out is dig into the problem a bit. We have to understand why some of these choices were made. So if we look here, we have got, what was this? This was a Symfony 1 controller. Is anyone familiar? Did anyone use Symfony 1 here? Yeah, a few people. Okay, good. You have a special place in my heart. So we've got some code that looks important, but not that easy to understand at the top there. And we've got a block of commented out code. In fact, it's quite a big block of commented out code, and it continues up there as well. And we've got 3 almost identical looking methods at the bottom. We've got execute download, execute download old, and execute old download. Right? Again, this is code that found its way into production. Nobody ever said, you're a fucking idiot, what are you doing? For some reason, it was merged. I don't know why. Okay, so we need to kind of start understanding what we're doing, right? So when we go ahead and refactor this, we need to do a bit of detective work. And we've got tools that can help us do that. I don't have access to the ticketing system anymore that we used for this company, but I can infer some things just by using Git. So if I git blame, I can see here that we've got this action here, and we've got on one day, Geordie added some code. And on the very next day, he commented it out. So let's look at this commit and kind of find out why. I think this is going to be give us the information that we want. So if I just have a look at that commit, I can see in the summary, he added a task class. Now, task classes, for people that aren't familiar with Symfony 1, they're like your Laravel artisan commands or your Symfony console commands these days, or whatever it might be in other languages and frameworks. You'll have to kind of infer that for yourself, I think. So let's have a look at that builder task class. What we've got is actually a line-by-line copy of the commented out code that we had in the controller. So actually what he's done is he's just done that copy and paste anti-pattern again and then gone, well, I don't need that anymore, I'll just comment it out. So what it appears to have been is that maybe that code was too heavy to run in a request cycle, so he's moved it into some sort of asynchronous process. So then we can just delete that out. We don't need it. Let's just get rid of it. We know that that code exists somewhere else now. But let's deal with these three methods here that some idiot has done. So again, if we just use git log on that class, we can see that I've got two commits here that are relevant to that file. Both have almost identical commit summaries, sequential ticket numbers, and committed 3 hours apart. If you take time zones into account, they were committed 3 hours apart of each other. So this is indicative, I think, of two separate lone wolves working on the code and not actually talking to each other. Because one person's fixing a bug, someone else is fixing a bug, and neither of them have bothered to talk about what they're doing. And I think probably what's happened as well is one said, I'll call this action execute download old or whatever, and the other one's probably had the same idea, had a merge issue, conflict, and then just decided to move the word old to the other end of the action. So they weren't talking to each other. So if we look at one of the commits here, though, what this code was doing, this is the template code here, but what this code was doing was saying, you can download some CSV files that we have generated from our database. And we can see here that we've got the current, in this commit, the current download was renamed to old download, or download old even. And the download method was changed to give some sort of new format. And there's some logic around, are you allowed to have this? So it looks to me then that some clients are allowed to download some new format, some clients aren't, and that's what we're doing there. So we can kind of infer what the decisions were being made when the developers were working on this. So we can just go in, and actually these two methods were just clones of each other with different names. So I'm just going to delete one, and then what we can do is just wherever it's used, we update the reference to it. And we're left with execute download and execute old download, I think it is. How can we, let's think about how we can make that a bit more familiar so that we don't end up with execute old download later on down the line when we add new formats. Let's just call one version 1 and the other one version 2. And then when there is a new version, then we'll have version 3, and it becomes much more easy to figure out what's happened in that kind of life cycle of the project. So again, that was kind of easy. How do we stop this thing happening before? Right. Invest time in educating your developers. Make sure that your developers are up to date with object-oriented programming. Make sure that you put effort into developing them, talking to each other as part of project management as well, get them talking to each other. We all joined this industry to avoid talking to people, didn't we? But I've got news for you, it doesn't work. Like, you have to talk to people more, probably, in this industry. And whenever you see one of these lava flows forming, you need to have the ability to say to your management, like, we're going to stop here and we're going to redefine this for a bit, because otherwise we're going to end up in a whole world of shit. So the next one, we're going to move on to some more interesting things now. That code is a mess. So if you overhear this in the kitchen, that code is a mess. Making a change in one place breaks something somewhere else. Who's had that experience? Good. I always like to see when most people have had that. Okay. Sorry. That means in your system, you probably have some noodle code. I mean, it's actually spaghetti code, but the best images of spaghetti that I could find were noodles. So I've gone with that. So symptoms of the spaghetti code is that you can't reuse anything. It's impossible to reuse stuff. Objects are frequently named as processes. I mean, I've worked in places where we had objects called get something from third-party web service or something. Like, the actual object was called that, not a method. There's minimal relationships between the objects in the system. You've got lots of object properties, methods, take no parameters whatsoever, and they use class or global variables, like usually toggles as well. It'll be if this internal thing is set, then do that. And you're going to have massive complexity throughout the system. Staff that actually understand OOP tend not to hang around for very long. They realize that it's all crap and they bugger off again. There are side effects everywhere within the systems. I'm sure everybody's familiar with problems like that. And the application performs badly. So causes of that, programmers that don't know object-oriented programming. No actual mentoring, no code reviews, the tendency just to go, all right, let's merge it in, we need to release it quickly. No actual thought of architectural design before implementation. And developers, again, sort of these lone wolves just not talking to each other, working completely isolated. And one other symptom of spaghetti code is commit messages like this, right? We've got things like testing, I hope this works, or whatever, or why is this thing not working? And often there's some sort of swearing at some sort of third-party API as well in commit messages. Sometimes, though, just quitting Vim is hard. So this here, this code was code that I inherited for a company that I joined, and I inherited it from a bunch of guys that had just come out of university and were building something. And it was a custom framework behind a WordPress installation. There were helper functions scattered throughout files. There was no actual class structure. And the routing for this application, it took me 2 days to figure out why I couldn't get the routing working on this application. In fact, or see anything that I was meant to see. And the reason was I'd set it up with Nginx on my local dev machine, and actually the routing for the entire thing was done. There were 300 Apache rewrite rules. And that was it. I mean, I was there thinking, I'm meant to be a senior programmer. Why can't I get this fucking thing working? But actually, no, it was just, I hadn't noticed the htaccess. And once I switched to Apache, things started, well, I say started working. Nothing ever really worked. So in this code, we've got this get new PDO instance method here. PDO is, for people that don't do PHP, that's your database connection. That's your abstraction for the database. There are global variables scattered throughout the system. Has anyone spotted this one yet? We've got a create client method that tells us that it's expecting an email, but we're sending through 3 parameters where we're actually calling it. So it only wants one thing, but we're sending 3 things. And what actually should it take? Does it want an email address or does it want a username or what? Who knows? Okay, we've got more of this get new PDO happening here as well. Just for the hell of it, we'll always return true from here. And this was the application's front controller. And I say front controller, I say controller loosely. It's an absolute mess. It was horrible, absolutely horrible to work with. The code was so bad that obviously, like debugging like error logging and debugging was a farce. So this is the database connection script that I've got here, right? We've got this PDO get new PDO instance method, and again we're calling it every time we're making a database query. We're requiring some sort of config file. The config file itself was impossible to understand. We inherit some variables from that config file. There's some sort of horrible condition thing happening here based upon what database you want. And we're just going to overwrite those connection details that we've just inherited from the config file. And we're going to do the same thing again. We're based on some other condition. And again, we're just going to keep doing this thing here. Let's make sure that exceptions are always shown to the user when we can't connect to the database. And this one here, you know, that get new PDO instance method, this creates a new connection, opens a new connection every time we make a query. We don't reuse connections at all in this code here. Some pages had 40 or 50 queries on. That's 40 or 50 connections being opened up to the database. It was ridiculously slow, so slow. On my development machine, it took 30 seconds to refresh the page. And I said to the CPO, I need to refactor this, I need to improve this. He said, it doesn't matter, we'll just buy a bigger server. I said, I can only make 2 changes a minute. So this was the config file. There's no validation. It's very easy to make mistakes, impossible to understand. There were connection parameters for things that didn't exist, and there were connection parameters that should be there for things that existed that we didn't know existed. This application had 7 databases on it. Only 2 of them were known about. Some of them were just hidden on web servers, which I found out as I was making changes. So how do we refactor that? I mean, we're in a whole world of shit with this one, aren't we? The very first thing to do is start encapsulating stuff with getters and setters. That is absolutely, when you've got spaghetti code like this, put some structure in. It doesn't matter what the structure is, but you need to put something in it. So the first thing we can do with this config file, for example, I mean, everything's committed into the code, into Git anyway, so you know it doesn't matter if I just create a concrete class with all this information in, because we can sort that out later on. So I'll create a config class just with some constants and some getters and getters on there as well. And also create a database connection class. And the good thing about this database connection class now is that we can add in a basic connection pool. So we can say, you know, do we have this connection open? Let's reuse it. Or, you know, we just have information about the connections we've got there. Again, it's not perfect, but it's better than it was. And we can start adding validation to connection requests as well. So we can say, do I know about this database? Yes or no? And if I don't know about it, then I can throw an exception. And I can choose whether or not I want to show that to the user, like they were doing before. And now I can reuse connections. I don't need to create a new connection every time I want to make a query. And with so if I add a create connection method here as well, we can reuse that, and we can use those static config getters that I just created in that config class. So we can actually make decisions now in here rather than distributing that knowledge throughout the system. And data storage stuff can be put now into a repository as well. We've got a very simple kind of architecture evolving now from this. We had this big ball of crap, and what we're doing now is just beginning to extract out some sort of architecture that makes things easier. And we can start using that connection manager that we just created. And obviously this is only kind of like scratches the surface of everything that we could do in there. but we're actually thinking now about, we've got a path to go on to move forward with. So let's think about plucking reusable components out as well. We still have the problem with the create client method. So we need to think about what we can do with that. We're still saying to it, here's an array of data, or here's 3 parameters I'm sending you, but use what you want. So this is where we're doing it here. I don't know here if it wants an email address or if it wants a username. We're passing in a username, but apparently it wants an email instead. The method signature says I want an email address. What we have to think about, though, is even consistent bad code is better than something that's inconsistent. So I'm not going to bother going and refactoring the hell out of everything at the moment. But what I want to do is just make sure that I know what I'm sending through at this point. So we've got this, and I can just create a client DTO object, right? Which just says, there's the information that I want in the constructor, and then I've got getters for that as well. And then when I actually come to use it, I can just pass in a client object there. I'm sure people here are familiar with OOP, so you kind of understand what's going on anyway, but all we're doing is just creating actual objects from the crap that we started out with. And what's going to happen as well as you're going through spaghetti code is you're going to find other lava flows, and you're going to find other antipatterns in there. And you need to eliminate them and take the same steps to eliminate them as we did before. And the point is you need to try to understand the decisions that these youngsters were making when they were writing that code. So how do we stop this from happening again? You need to understand what you're building before you build it, okay? So spend a bit of time understanding the domain, thinking about what business decisions you need to make. And also develop a model prior to implementation rather than concurrently. Now, that doesn't mean do waterfall, because we know that's crap as well. But talk about what you're going to do before you do it with your colleagues. Just bounce some ideas off. It takes 5 minutes to say, I'm thinking about using this design pattern, or I'm thinking about doing that, and then just get some feedback on that. And that's how we deal with spaghetti code. It's kind of it's kind of easy when you look at it. It's just knowing where to start. So this is one of my favorites. Don't touch that class. It's the heart of the application. If you ever hear that, you may have a problem. I was chatting to somebody from another company at a conference, and we were talking about this. And he said, "Oh yeah, we've got one of these. It's called application business controller or something like that." As he said, it was the heart of our application. And he had like 13,000 lines in it or something like that, and nobody ever wanted to deal with it. That's a blob, or a god class, as it's otherwise known. In fact, I've got a note here. It says it was business case controller, and they had no tests on it either. So symptoms of a god class or a blob: you'll have a single large class with a huge amount of properties and methods. More than 60 is typical. That single class has a really disparate collection of things that it does. It doesn't actually have one job. It's got so many different jobs. And it's too inefficient to be reused. You can't test it. And it uses excessive resources, even for doing simple stuff. So causes of that tend to be things like functionality is added piece by piece, and nobody ever thinks about refactoring stuff out of it. Usually people are too afraid to by that point as well. A lack of object-oriented architecture in the system. Lack of any kind of architecture, actually. And then no architecture enforcement. So God classes come because people don't understand architecture. So I'm going to show you one now. This class, this is a really good one to show, actually. The idea behind this class, this came out because I was working at a company that had a bunch of records stored in a database, and they needed to create reports, again in CSV. But the queries took forever to run. The queries took about 10 minutes to run. And we were trying to do this on a request cycle as well. We're trying to do it on the fly. And of course, what we should have done was done projections or kept data up to date and stuff. But we were just storing kind of social media events in a table. So like this click happened at this time or whatever on adverts. And we just kind of needed to pivot the data and change it around a little bit to show to the clients. But it took forever. But what we discovered was that if we used temporary tables and pivot tables in the middle to aggregate the data, it ran a lot quicker. But those tables needed to be created on the fly. Like I say, it was a horrible solution, and what we should have done was just actually stored the data properly. But we came up with this class. In fact, I came up with it. I'm going to admit it was me that wrote this shit. So this is why I'm showing it to you today. There was a lot of documentation needed to be able to use the class, in the class itself as well. I wrote a massive, massive comment about how to use it. The client code needed to know about the internals of that class and able to be able to use it, because we had to pass in a config array in the constructor to say, I need you to set up this chain of tables in the middle of this thing in order to be able to work and get the report that you want to. And it was horrible, absolutely horrible. We had other developers. I mean, I wrote it. I was not proud of it. Well, I was proud of it at the time because I didn't know any better. But other developers would take it on and they'd say, oh, I need to work on this class. And they'd take a day to prepare themselves mentally to go and work with this God class that I'd written. So how could we go about refactoring that? Well, when you're faced with a God class, the first thing to do is identify relationships according to the contracts. Now, that's just a fancy way, I think, of saying, make a list of the functions and see what ones are similar. So if we look here, we've got a bunch of functions in this class. This is only a subset of them. But we've got something about generating these pivot tables, something about getting SQL queries for those actual reports that we want to download. So they would be selecting from those from the pivot tables. And then there's some sort of query builder thing happening as well, because we're building up the queries based upon what we're sending in that god-awful config array that we pass in the constructor. There's one thing to remember. It's going to get worse before it gets better when you're dealing with a God class. We're going to make a lot of mess in the process. But now that we've thought about those contracts in the code, we now need to identify natural homes for them. So with this one, for example, so the query builder stuff, well, actually, I can just create a temporary namespace and put the query builder things inside it. So I can create a query builder class and just dump all that crap in there. And then I can inject it into the report factory class as a dependency. So in the constructor, I can say that I just need this. It does mean, though, that the controller code, where before it was adding the query builder stuff itself on the factory, it now needs to know about something else. Like we're breaking which principle is this? Don't talk to your neighbours, or only talk to your neighbours. I can't remember off the top of my head which principle it is. Someone shout it out for me. Law of Demeter, that's it, yes. So we're breaking that. But like I say, it's going to get worse before it gets better. But I can delete those from the report factory now. We've kind of just gone, let's get rid of some shit from there. The next thing to do is take that temporary table stuff and again, create a temporary table class. And we can define an algorithm for generating the temporary tables within that class itself. So it becomes basically a small factory itself. And we can delete all of that. And then we've just got these other ones that we can just put inside a metrics query class as well. So now we've kind of extracted some stuff out, and it still works. The point of this as well is that you know what you're starting with, you know what you're ending with. One of the very first things that you should do is just put a test in to say, when I put this in, what comes out the other end of this big black box of crap. So we need to start thinking about removing couplings. So let's have a look at this, what we've got here. So we've got the controller, which has a dependency in the report factory because it's a client of it and it uses it. The report factory has a dependency on the controller because it needs to pass in what it wants. Both of them have got a dependency on that query builder thing that we've got. The report factory has a dependency on that metrics query, and then the metrics query thing has a dependency on the temporary table, and just for good measure, the temporary table has a dependency on the query builder as well. It's bollocks, isn't it, to be honest? It's rubbish. But the first thing that we can do is think about tidying up where we use it. The first thing that I would do is remove the coupling from the controller. So if I create a metrics report abstract class, the child classes of that abstract class can then be responsible for setting the table algorithms themselves. So I've got the abstract class here. I'm going to say, like, here's a function I expect you to pass in. And then the controller can just say, actually, I want this report. I want whatever report it is, just give it to me from the factory. So we've got rid of all this crap from it, and we can just say, I want this report, give it to me. That means now that we've kind of changed the dependencies a little bit. The controller only depends on that report thing, and we've moved that crap somewhere into the actual report generation stuff. We don't need the query builder in here anymore because there's no more array configuration. So in the metrics report stuff, we don't need it. Each child class can just make the query directly now. So we can get rid of a whole load of crap there, and we can just say, make the query that you want. We don't need to dynamically generate queries anymore based upon what we're doing there. And if we look at what we've got here, we've now removed a coupling from there as well. And in fact, the metrics report can just depend directly on the metrics query, and we've removed that coupling. And actually, what we've done now is completely isolated that shit class that we had in the first place. So we can just delete it. There we go. We've dealt with the God class by extracting some stuff out and then figuring out that actually, by changing how we think about the things a little bit and putting a bit of OOP principles into it, we've actually got rid of something that was really big and unwieldy and horrible. But it's still a little messy, so we can have a bit of fun with finishing up. I quite like the decorator pattern, so I think we could, it's not the best solution, but we could chain those SQL statements together that we need to generate the chain of temporary tables, those intermediate tables. We can just use the decorator pattern for that as something quick and fun to do. So if I've got my class here, so I can create an interface, the temporary table, and my child classes can just implement that and send, and we can use that pattern there. It doesn't have to be perfect, the solution. It just needs to be a little bit less shit than it was before. So once we've done that, though, again, we've got our pseudo UML diagram of what we had, and we've created an interface here. We've got no dependence on that query builder anymore, so that can just go. We don't need it at all, and we've tidied things up quite a lot. Now, all we've got is this metrics report thing, and we're going to say each metrics report can just be responsible for defining what SQL chain it needs, and we do that just in here. And then finally, what we've done is got rid of that metrics query thing, because all we're going to do is depend directly on that temporary table interface and the child classes that provides. So we've got that. So we've gone from one massive class to a couple of interfaces, a couple of abstract classes, and obviously the concrete classes, the child classes, will do their thing. But we've got now something that is actually testable. We've got small units doing one specific job, and we've refactored something big and huge into actually properly architectured systems. And then I can delete everything from that temporary namespace that I set up. So we're doing some cleaning up now. We can delete everything from there, and we can delete that original reporting folder that was full of shit. And that leaves us with something a little bit more clean and easy to use. And it means that developers aren't going to need 2 days to prepare themselves to work with your classes anymore. So how do we stop this happening? Code review. I wish at some point when I was building that, my bosses had said to me, don't be a fucking idiot, don't do this, it's not going to work. Unfortunately, we don't always do, well, throughout our careers, we don't always get the code reviews that we want or that we need. Okay, so we're going to move on to project management Antipatterns now, just to finish up. How are we doing for time? We've got loads. We haven't got loads. Okay, so at some point you might overhear something like this. And somebody says, the project is almost finished. We've been a great team. Everyone got on so well, worked so hard, but it's going to be an absolute disaster. And this happens, this is somebody who's suffering from fear of success. It's those side projects that you start and you never actually do anything with. People involved in the project begin to obsess over things that will go wrong, so they never release it. Insecurities about professional competence arise. People start fighting with each other as well in the team. Irrational decisions and inappropriate resolutions to conflicts are taken. And as well, negative publicity is generated on the project by people within the project as well. Now, causes of that is people have got termination issues. They form relationships within the team and they don't want that. They have trouble understanding that when the project is finished, the team will be broken up. They don't want that. So they build relationships between each other, and they can't handle that somebody might get moved onto a new project or whatever. They've built up roles and statuses within the team, and they don't want, if somebody become a senior consultant in a particular project, they don't want to go back to being just normal Billy at the end of it. And then sometimes people are just like batshit crazy, so you have to deal with people like that. One way of mitigating that is to declare success at the end of the project. And I don't mean George Bush on top of a ship saying mission accomplished, we've killed ISIS or whatever. What you do is when you're coming close to the end of a project, you say, yes, this is it. We're about to launch and it's gone really well. If there are any issues, we'll deal with it. And celebrate achievements and praise team members appropriately as well. At my builder, where I work, every Friday we have a meeting where we talk about the things that we've achieved that week, and everybody gets on board, and then we have cake and beer. It's a great place to work. You should definitely come and work with me, everybody. So that's the fear of success. And then finally, this one, this old chestnut. We spent 6 months waiting for requirements from management. They're going to cancel the project unless we make some progress on it. We've got 4 weeks to do it. I'm sure we've all been there. This is the fire drill. And what happens with that, symptoms of that, is management makes you wait because they don't know what they want, basically. They prevent development teams from making any progress by giving unclear requirements. And then after a while, they say, hold on, we've wasted a whole load of money on this, paying you to not do anything. We need to focus somewhere else. And the cause of that is just that they've got too much on their hands. They can't put any focus, can't give any focus into anything. So how do we deal with that? You need a project manager who's going to shelter development teams. You need to have iterative progress. Now, iterative progress means both internal progress, which is things like working on components and architecture and stuff that you can then apply into your proper project when you're actually working on it, and then external progress, which is that where PMs should be working on reports and pushing management for the requirements. Some final notes just to finish up with. Add tests. Always add tests. When you're refactoring stuff, add tests. If it's not testing, is the cause of a hell of a lot of this stuff. Pick the low-hanging fruit. If you know the 80-20 rule, it applies here. 20% of the effort will give you 80% of the payoff. So just look for the stuff that's easy to deal with now, refactor that, and then find the next easy thing that's there to refactor. Understand the tooling that you have, like we used Git and we used copy-paste Detector and stuff for doing a lot of stuff here, and it helped us get rid of the crap that we had early on there. Hire developers. with different understanding and knowledge and experience to what you may normally hire for. If you're a Laravel house, hire somebody that's used Symfony. If you do Postgres, then hire somebody that does MySQL. Not every time, but people will bring in a you'll have this melting pot of ideas and approaches and solutions to stuff, and you won't be golden hammering everything all the time. And invest in growing your team and in yourself as well. And you need strong leadership. You also need teamwork, everybody looking out for each other. But it doesn't stop there, because there's a book on SQL Antipatterns as well, because as a species, we also suck at doing databases. But obviously, so I've been covering this one today. You can buy it secondhand for a lot cheaper than you can buy it new. But I would say certainly if you experience any issues, or you do have these smells within your system, then definitely buy the book. I'm so sorry that I ran on for so long. Thank you so much, everybody, for listening to me. I don't know if we have time for questions. I'm getting that, but thank you, everyone. Thank you.